Hello all. Today we are going to discuss the energy stored in the flywheel. So here you can see typically the picture of the flywheel. Okay. So here the flywheel contains the three main parts: rim, hub, and arm. Okay. So here you can see the rim portion, a small rim portion you can see over here. Okay. The rim portion have the diameter and the thickness of rim will be very less or negligible, or we can neglect. Sometimes we neglect the thickness of the flywheel. Okay, and here you can see the hub part. Okay, where the shaft is connected, and here you can see the arms of the flywheel. Okay, and arms connect the hub and rim portion of the flywheel. Okay, now basically this already we are knowing about the flywheel is used to absorb the energy. Okay, and it releases the energy when it is required, or engine is not capable to deliver that much energy. Okay, when flywheel absorbs the energy, the speed of the flywheel increases, and when flywheel releases the energy, at that time the speed of the flywheel decreases. Okay, now we are going to derive the equation for the energy stored in flywheel. So let m be the mass of the flywheel. Okay, now here you can see the m is equal to mass of the flywheel in kg, k be the radius of gyration in meter, I be the mass moment of inertia, which is equal to mk square. N1 and N2 are the maximum and minimum speeds during a cycle. Okay, and which is in RPM. Okay, so I will repeat: N1 and N2 are the maximum and the minimum speeds during a cycle, represented in RPM. Omega 1 and omega 2 are the maximum and minimum angular speeds during a cycle, which is represented in radian per second. N is equal to the mean speed, and which we can obtain N1 plus N2 divided by 2. Similarly, omega is the mean angular speed, omega 1 plus omega 2 divided by 2. Cs is the coefficient of fluctuation of speed, already we have seen that part. Okay, and which is represented by N1 minus N2 divided by N, where N is the mean speed, and omega 1 minus omega 2 divided by omega. Okay, that is for the angular speeds. And we already know the kinetic energy we can able to obtain with the equation, that is E is equal to 1/2 I omega square. I would repeat, E is equal to 1/2 I omega square, which is also given by 1/2, where we are going to replace I with equal to mk square. Okay, where we can able to replace I is equal to mk square. Okay, where mk square into the omega square. Okay, and which we will get in Newton meter or joules. Okay, so as the speed of flywheel changes from maximum to minimum. Okay, during the cycle, the speed of the flywheel is going to change from the maximum to the minimum speed, because the energy is sometimes energy is absorbed, sometimes the energy is going to be released. So delta E, that is change in speed, that is the maximum fluctuation of speed, we can able to obtain maximum kinetic energy minus minimum kinetic energy, which is 1/2 I, or suppose 1/2 I omega 1 square for the maximum, minus 1/2 I omega 2 square, where omega 1 maximum angular speed, where omega 2 is the minimum angular speed. So what we get? I will take 1/2 I common, the remaining terms are omega 1 minus omega 2 square. Okay, I will expand this bracket: 1/2 I omega 1 minus omega 2 into the omega 1 plus omega 2. Okay, so what I get? I know that omega 1 plus omega 2 divided by 2 is nothing but what? Mean angular speed. See, check over here. Omega 1 plus omega 2 is equal to divided by 2 is the mean angular speed. So I can use this relation over here. So I will write half will go over there. I into omega 1 minus omega 2 divided by multiply by second bracket omega 1 plus omega 2 divided by 2. Okay. That is omega is equal to omega 1 plus omega 2 divided by 2. Okay. So this will become I omega into omega 1 minus omega 2. Okay. So this will close the bracket. Okay. Now again I can able to find out in terms of the coefficient of fluctuation of speed. Okay, omega 1 omega 2 over there. If I divide this with the omega, I will get the CS, the coefficient of fluctuation of speed. Okay. How to get that? I omega square, that is I am going to multiply and divide by with the omega term. Okay, so this will become omega square, omega 1 minus omega 2 divided by omega. Okay, then I omega square into CS. Okay, how? CS is equal to omega 1 minus omega 2 divided by omega. See, we have that relation already written over here. Omega 1 minus omega 2 divided by omega. This is what? The coefficient of fluctuation of speed. Okay, so that what we have used it over here, and we are getting I omega square into CS. Okay, now what I get? I will replace I with mk square omega square CS. Okay, because I is equal to mk square. Okay, now where k is what? The k is the radius of gyration. Okay, that we know. Okay, and which can be taken equal to the mean radius of the rim. Okay, that is what I am going to do. I am going to replace the k with the capital R, because what happens, the thickness of rim is very small, okay, compared to the diameter, because diameter of rim is huge and thickness of rim is very small. So I am going to replace the k with the R. Okay, so what I will get? M capital R square omega square C. The equation will become M R square omega M R square omega square CS by replacing k with R. Okay, over here I am going to replace the k with R, so I will get M R square omega square into the CO. So this will become a final equation to find out what? Delta E. To find out the delta E. Okay. Similarly, this I can able to expand in terms of linear speed, that is m v square into the CS, because v is equal to what? R omega. V is equal to R omega, that we know. So this relation also we can know if value of v is given. If value of v is given. Okay. Thank you. Now we will solve the numericals related to it.